All right, we're going to do a new truss problem from start to beginning. Some people are still having trouble with it, so I'll do a new one. Okay, so there's my cursor. All right, get rid of this real quick. Okay, now we have a truss here, truss that I made up. That's 10 feet, 30 feet, and then 20 feet that way. We got a pin support, so we got our pin support here, pin support, and then we got a roller support here. So the first thing is that a pin support is going to have two reactionary forces acting on it. It's going to go up this way. We have R A Y, uh, and then it's going to have another force this way. I'm going to do that a little too close. I'll call it R A X. And one thing I forgot to do is name the joints. So you got to remember that the joints are everywhere a beam uh, meets. So you got a joint here, got a joint at this corner, joint here, and a joint here. So this is joint A. We'll call this one B, C, and D. And then a roller support only has one reactionary force in the Y direction, RCY. The first thing we should always do is, can we solve for this truss? And we use this equation. We use 2J, 2 times the number of joints, has to equal the number of members plus the reactionary forces. And so if we look at the number of joints, 1, 2, 3, 4, we have 4. So 2 times 4 is 8. That has to equal the number of members. We got 1, 2, 3, 4, and 5. We got 5, and we got 3 reactionary forces. So 8 does equal 8. So we can solve this truss. Now, the first thing that we're going to do is we're going to sum all the forces in the x, y direction. And if we look at our truss here, we have a force going to the right and a force downward. Now these forces are loads that are on the truss. They could be anything that's either holding up or anything that's hanging from it. So we do the sum of the forces. This is that E little thing here, the sum, the sigma. And we got to set all that sum into 0. So if I look, I have an RAX and I have a 200 pounds. And that's about it. That's all the forces I have. So that's going to be RAX plus 200. That's equal to 0. If I solve for this, I get that RAX is equal to negative 200 pounds. All right. So now let's sum all the forces in the y direction. F of y. And we're going to set that equal to 0. So, okay. So we have RAY. We have minus 800 pounds because it's going downward, plus RCY, and that is equal to 0. Now the problem we have here is that we have one equation and two unknowns. And I don't know if you can hear that, but there's a plane passing over my house. Just gonna wait. Tea break. Now I don't know if I have time to edit that out, but okay. Now the plane is gone. I don't know if you guys could hear that, but that was pretty loud to me. Hopefully you guys can't hear that. That RAY minus 800 plus RCY equals 0. Now I can't solve that because I only have two unknowns. So my unknowns are RAY and RCY. And so what I need to do is I need to use the sum of the moments. and set those equal to 0. A moment is anything that causes an object to rotate, and a moment is equal to force times distance. So now I have to look at my truss and see uh, what forces cause my truss to rotate. So what I'm going to do is I'm going to pick a pivot point and I'm going to color that green. I'm going to say that my pivot point is right here at A. That means that it's going to rotate around. It's either going to rotate this way or it's going to rotate the other way. So depending on which way the force is acting. So if it's rotating clockwise, that we're going to say it's positive. I'm sorry, we're going to say it's negative. Erase that. That out of the way. We're going to say it's negative. If it's counterclockwise, we're going to say it's positive. That. So we got to look at each force and see if it's causing it to rotate clockwise or counterclockwise. So if we look at this force here, 800, because it's going downward, it's actually causing this to rotate clockwise. This 800 pounds right here, is causing a clockwise rotation, which means it's going to have a negative moment. And so I have to look for the distance, which is the lever arm, which is the 10 feet. So 10 times 800, but that's a negative. So I get negative 10 times 800. All right. I have another force here, the 200. That's also causing it to rotate clockwise because it's pulling on this lever arm here and causing it to go that way. That's another negative. And the lever arm is actually the 30 right here. So that's another negative 30 times the force, which is 200. Okay. And I have one more force going up. So we don't know if it's positive or negative. We're going to say it's plus 30. That's a big 30 times RCY. That is equal to 0. So now I need to solve for RCY. So negative 10 times 800 gives me negative 8,000 minus 6,000. Right? So 30 times 200 gives me 6,000 plus 30 times RCY. So if you add these two together, well, subtract them, you get negative 14,000 plus 30 RCY equals 0. So now I can solve for RCY. I'm going to add 14,000 to both sides, plus 14,000 on this side as well. And then I get that, well, I'm running out of room, but I get that 30 RCY is equal to 14,000. And now I'm going to divide both sides by 30. And I get that RCY, if I can write over here, RCY is equal to, well, I gotta get my calculator out first. Here. So I have 14,000 divided by 30. RCY is equal to 466.67 pounds. There. I also have that RAX equal to negative 200 pounds. Now, I need to go back to some of the forces in the y direction, and I need to solve for RAY. So RAY minus 800 plus our CY, which we found to be 466.67. That's equal to 0. So now we're going to add, so minus 800. And we get that RAY is equal to, or minus, I should say. Let me not skip any steps here. So what I'm doing is I'm adding these two numbers together, and I'm getting minus 333.33 is equal to 0. I'm going to add 333 to both sides. So, and then I get that RAY is equal to positive 333. So RAY is equal to 333.33 pounds. So now I have all my external forces. So the whole point of this is to solve for all the external forces on the outside before we move on to the internal forces. So now, what I'm going to do is well, first of all, I'm going to save this. Let's save this as example 2. Yes. That way I can refer back to it. And so I'm going to set a new one. All right. And so if I go back, well, actually, save it here. Okay. All right. I don't know where it's saved at. I forgot. Oh, right there. That's example 2. Okay. So I got to remember these. RCA or RCY is 466. So before I go on, let me write those down. So I'm definitely not going to remember those, and I can't keep it open at the same time. So we're going to say RCY is equal to 466.67. RAX is negative 200. And then RAY is equal to 333.33 pounds. That. Okay. And then we have a truss here, like so. Okay. Alrighty. Let's open up a new file. Alright. So let's redraw our truss real quick so we can see what we're doing. We have a truss here, and then we have point A, uh, point B, point C at the joints here, and then point D. So now we got to solve for the internal forces inside the beam. Okay? So we got to go inside the beam. So now what we're going to do is we're going to do the sum of the forces in the X and Y for each joint and solve from there. So if we start from joint A, there's another plane. Don't know if you can hear that one. I don't know if you guys can hear it or not, but it's kind of bugging me. All right, there we go. All right. So I have my joint A, and if I draw the free body diagram of joint A, so here's the corner part, this part right here. I have a beam going this way, and we're going to call that AD. We have a beam going this way. We're going to call that AB. And we have a reactionary force going this way, which was RAY. which was 333.33 pounds. Then we had another reactionary force going that way, which was RAX equals negative 200 pounds. Okay, so I have my free body diagram here. Now, one thing I need to do is I need to solve for these angles at joint A and C. So that's one thing I didn't do. So remember that this was 10, this was 20, and this was 30. So, okay. So if I look at this right triangle here, I have 10 and 30. So I have tangent of theta is equal to the opposite, right? So if we use SOHCAHTOA for a right triangle, we have the opposite, which is 30, over the adjacent, which is 10, like so. So then if I take the inverse tangent of both sides, inverse tangent of this side, so I can make room. I get that theta for A, I'm going to call it theta A, is equal to, see, I don't have tangent on this. I don't really. Oh, I should. Oh, it's right there. So 3 tangent. And it says negative, but that's because I have it on radians. And I want it in degrees. Now let's clear that. 3 tangent of. Oh, wait, I'm doing tangent. I need to do inverse tangent. And I just realized that my calculator does not have inverse tangent. There it is. Gotta make it bigger. Okay. Now we can do so tangent, inverse tangent gives me 71 degrees. So 71, go back to it, 0.57. I'm just gonna round up, or 5.7. Yeah, 5.7 is fine. So I'm gonna do the same side. I'm gonna do the same thing for this side. So tangent of theta c is equal to the opposite, which is 30, divided by the adjacent, which is 20. So then theta c, so 30 divided by 20, inverse tangent, that is 56. 56.31. So those are my two angles that I need to know. All right, so that means that this angle here is 71. Well, 71, not 72. Is that? So this is 71.57. All right. So now this is gonna get kind of tricky because I don't draw very good with this, but I'm gonna extend this out just a little bit so it can be a little bit more clear. Here goes. That's not so crowded. So everything is on an x and y axis. So I have, this is my x and this is my y. The only beam that is not in x or y is AD. AD is actually in both x and y. So I got to break it up into its components. Like so. So AD has an ADY, so a y component. It also has an ADX, an x component, right? So I'm going to have to solve for these. So I'm going to do that now. I want to write the components ADX and ADY in terms of just AD because I don't want to just solve for ADX or ADY because it just gives me the length or the force in the x or in the x direction of those two. What I really want is the total force in that's AD. So I can rewrite these terms here and here in terms of just AD. Then I can use that to solve. So first, we have the angle, and we have the solve for ADX. So if we notice that this is the angle, the adjacent side is ADX, and I also want it in terms of the hypotenuse. So if I have an adjacent side with the hypotenuse, I'm going to use cosine. So cosine of theta A, which we know is 71.57, is equal to the adjacent, which was ADX, over the hypotenuse, which is AD. Now, I'm gonna cross multiply and get AD times cosine theta is equal to ADX, like so. So now I'm gonna solve for the y component. So because it's the opposite, and I want it in terms of the hypotenuse, I want sine. So sine of theta A is equal to the opposite, which is ADY over AD. And if I solve like last one, I get that AD times sine theta A equal to ADY. Okay. Now I can solve for I can write everything in my x and y. Well, let me say that again. Now I'm going to sum all the forces in the x direction and the y direction and set those equal to 0. See what I can solve for. So first for my x direction, I have an RAX. Right, that's from here. I have an AB from the member AB right here. I also have an ADX plus ADX. And all that is equal to 0. Right? The problem here now is that I know what RAX is. I actually know that. So I'm going to underline everything that I know. I know RAX. I can rewrite, I don't know what ADX is, but I can rewrite it in terms of AD. So if I do that, I get RAX plus AB plus AD times cosine theta A is equal to 0. Now, I still have another problem. I know what RAX is. It's negative 200. I don't know what AB is. I don't know what AD is. So what I'm going to do is I'm going to move on, and I'm going to come back to it, do some of the forces in the y direction, and set that equal to 0. All right, so the forces that I have in the y direction are RAY, AY, plus ADY, and that's equal to 0. So RAY plus ADY, which happens to be AD sine, oops, theta A, that's equal to 0. So now I can solve for AD because I know what RAY is and I know what sine theta A is. It's 71.57. So if I rewrite everything in there, I get that RAY, which was 333 pounds, 0.33, plus AD sine 71.57, and that's equal to 0. Now, because I'm running out of room, I am going to rewrite the next step. So you're going to have to actually do the algebra on this one. But AD then is just equal to negative 333.33. I just realized, oh, no, nothing. Divided by sine 71.57. So now if I take my calculator, move that up there, I'm going to get 333 divided by 71.57 sine equals 351, negative 351. So hopefully that is correct. Oh, right here, 332 divided by that gives me, so AD is equal to negative 351.35. So now I have what AD is. So if I rewrite this, I know RAX was negative 200, negative 200 plus AB minus, because this is a negative, so 351.35, and that is times cosine of 71.57, and that's equal to 0. So then all I got to do is subtract the, or actually add, where's my cursor at? I always keep losing my cursor. So I can combine these two numbers together, because the 351.37 times cosine 71.57, that's a number. It's a negative number. I can actually add it to the negative 200. So that times 71.57 cosine is equal to 111.01. So if I rewrite this, if I combine these two together, right, plus 200, I get that, if I combine these together, I get that AB minus 311 0.07, and that's equal to 0. So now so that means that AB has to equal positive 331.07 pounds. So now I have AB. AB is a tension force because it's positive. AD, which is this side right here, is negative, so it's a compression force, like so. So now I have members AD and AB. So I'm going to save that, save as example 2 part 2. Yeah, that'll work. So I'm going to write this down again. I have that AB equal to 331.07 pounds. So I'm going to need that number pretty soon. So I'm going to go File, New. So if we go back at it, our truss is here. We just did joint A. We still have B and C, like so. And I got to remember that there was a load of 800 pounds here. This is joint B. So if I draw the free body diagram, I have B in the center. I have a truss going this way. I have a load of 800 going this way. And I have a beam here. So this is AB. A beam going this way. This is BC. Now I'm going to do some of the forces in the x direction. Set that equal to 0 so I can solve for anything that I need to solve for. And right here I have AB plus BC, and that's equal to 0. AB was 300, and so in the previous problem, AB was positive 331.07 pounds. So watch what I'm going to do here. I'm actually going to make this a negative 331.07 pound plus BC equal to 0. Now, the reason why I put negative here is because of Newton's third law. When you have tensions, and depending on which side you look at it, they can either be positive or negative. So let's say, for example, uh, I'm pulling on a string, another person is pulling on a string. We're both pulling on strings together. So let me see. Let me see if this will come up. See this one? So right here, I'm pulling on a string or a cable right here, just like this. Okay? One force is going that way, another force is going that way, and they're equal to each other because the string isn't moving and it's tight, it's taut, right? So if you look at it, I have one force. So let's say I have a tension pulling this way, right? That's positive. That's a positive. Let's say it's like 50 newtons. Then this one is pulling that way. That's also 50 newtons, but it's in the different direction. That's a negative. So when you have tension forces, depending on where you look at it, you're gonna have the same magnitude or the number uh, of of force in it, but a different direction. And because I'm looking at it from the point of view of point B, it seems like if the other problem it was a positive AB going that way, that means that the force going this way has to be negative because it has to counteract the other force from joint A, right? So that way it doesn't like pull to one side. So then that means that when I solve for BC, so if I add 331, that BC just equals 331.07, and that's also a tension, like so, right? Now it's time for the sum of the forces in the y direction. Equal to 0. Remember that this is point D, and this is point A, or joint A, I should say. Okay, so I have a beam here. Actually, I should draw it down here. This is BD. There we go. So I have BD minus 800 pounds. That's equal to 0. That means that BD has to equal 800 pounds. That. So now I've solved for BD and BC. So now I got to look at joint C. So joint C. You know what I just realized? I don't know what the other angle was. I know this was 71. This was like 56. So let me open this under. I think there we go. So I have 56.31. Okay, I'm gonna need that 56.31. So now let's draw a free body diagram. So I have joint C. I have a beam going this way. That's DC. I have a force coming up here. That's RCY. Then I have a member going this way, which is BC, which we solved in the previous problem. So now, once again, I'm going to break up my DC into components because it's going in the X and Y direction. And so it's going to have a DCY, a DCX. So it's going to have those two components. So I'm going to sum all the forces in the X direction. that equals to 0. So I have BC plus DCX, and that's equal to 0. So my BC from my previous problem, it's actually right here, was 331.07 plus, well, DCX, I don't know what that is, but I want it in terms of DC. So I'm going to use SOHCAHTOA again. And this time it's going to be the adjacent angle, so it's going to be cosine. So cosine of 56.31, and that is equal to the adjacent, which was dCx divided by dC. That means that dC times cosine of 56.31 is equal to DCL. It's getting bad. That I cannot even read that myself. Let me just erase that. Let me actually make it a little bit more clear. Whoops. Okay. So I'm going to continue this on over here where I have more room. So I'm going to multiply both sides by DC. So then DC cosine of 56.31 is equal to DCX. So now I can add that in to my equation right here, plus DCX, which I found to be DC cosine of 56.31, and that's equal to 0. So now I'm going to subtract 331 from both sides, and then I'm going to get that DC then is equal to, well, okay, so before I skip steps, I subtracted to both sides, and so now I have DC times cosine 56.31 is equal to negative 331.07. So now I'm going to divide both sides by cosine 56.31, and then get cosine 56.31. That cancels out with this one. And what I'm left with is DC is equal to negative 331.07 divided by cosine of 56.1. There you go. Now if I do that, I get, this was an old one, right? Which one was this one? Where did I get 311 from? I don't even remember where I got 311 from. Anyways, so I got 331.07 divided by 56.31 cosine is equal to 596. This is equal to negative 596 point, wrong one, 0.84. And then that is a compression force that's negative. That's my DC. Now, what you can do now is you can try to see if you're correct. So hopefully if I did everything correctly, I get the right answer. So the way I'm going to check is I'm going to use something called MD Solids that you can download on your computer. For some reason they're not working on our laptops. So hopefully you can have access to a computer at home that you can try. And so I'm going to have, I believe it was 200 and this was 800. Okay. So I'm going to open up MD Solids. There it is. Can I move this over? That won't let me. I'm going to go to trusses. It keeps bringing it back over here. So it's new truss. I'll do it on this side so that way, and I'll pull it over. So I had that way. That way. That way. So what I'm doing now is you can't see it, but I'm making a truss here, and I'm going to show you. I'm going to see if I got it all correct. So then I'm going to add supports. Now I'm going to add the loads. Hmm. Now we look at it here. Let me see if I can just bring this up. Oh, what happened? Compute file. Copy to clipboard. What I'm going to do is I just realized I made a mistake. And it probably, now the way I did it, the way I did it was not wrong. And you'll see why. Post it there. That's the answer what I should get. So I got 351 for this guy, which is what I got. 200, 311, 800, 560, 466 is what I got, and 311 here, and then 560. If you notice, I actually got 596, and the reason why is because when I did BC over here, I used 331. I don't remember where I got 331 from. AB. But on my calculator, I actually got 311. So, which means that I read this wrong. That's what happened. So actually, this should be, so if I go back to my answer, this should be 311.07, which then, cross that out. This one should also be 311.07 right here. And this should be 311.07 negative. Plus that one out. That. So did I do this whole complete answer wrong? Well, yes, because when I came here, as you can see, let me actually close this. So as you can see, right here in my history, okay, sorry. Right here, I got 311. That's where everything went wrong. Was because for some reason I read it as 331. Don't know why. I just did, right? So I did it correctly. I just wrote the answer down wrong. So let's go back and check to see this answer. So that means that this would change this to 311.07. And so this would change this to 311.07 divided by cosine 56.1. So then I get 311.07 divided by 56.1 cosine equals 557. 557. This is a compression force. All right. So then if I look back at my answer, it should be 560. So what happened? Why is mine 557? And why is the answer computed by the program that I have 560? That is due to rounding. So if you notice that I put 311, so when I inputted everything, I said it was 311.07 divided by cosine point. Because if you look at it, it's actually 311. This whole answer right here. Can I reuse this answer? Use this answer here. And then there you go. Divided by 56.1 cosine. Still get 557. So somewhere, I think my angles are off. Oh, it's 56.31. Once again, it's kind of late at night and I'm making a lot of mistakes. So let's try that one more time. Let's see. Paste. Divided by 56.31 cosine. There we go. 560. So this just shows you that you have to be careful. Um, I'm actually going to leave that mistake in so you can see where I went wrong. And did I do the problem wrong? No. Did I copy the numbers wrong? Yes. I copied the numbers wrong. So I said that this was 331, but it should have been 311. And I went back and I showed you that I did have 311. I just read it as 331. And then that changed all my answers. So yes, if you make one mistake, it can change all your answers, but you just got to be careful. And luckily, I was able to check. So if you can get this MD solid um, program, it can actually help you get the answers that you need. So, and that's exactly what I got. 560.80. Got 560.86. Once again, just a little bit of rounding error there. Not a big deal. It's pretty close. Versus this one, which was way off. Right? Because I used 331. Or maybe I used 321. I don't know. But hopefully that helps. And hopefully I didn't confuse you there at the end with that mistake. But I'm going to leave it in there just so you can show that, I make mistakes too. So keep trying these. And I'll see you guys later.